So, hello everyone, myself Asta Mathania. Today we discuss about digital differential analyzer algorithm. The DDA algorithm generates pixels for a line segments by using incremental calculation based on the line slopes. Digital differential analyzer is a drawing algorithm used in computer graphics to generate a line segment between two specified endpoints. DDA algorithm is relatively easy to implement and is computationally efficient, making it suitable for real-time applications. However, it has some limitations such as inability to handle vertical lines and the need for floating point arithmetic, which can be slow on some systems. Now we discuss about the algorithm. Step 1, we start the algorithm. Step 2, we consider starting point as x1 y1 and the ending point is x2 y2. Step 3, we have to calculate delta x and delta y. Delta x is change in x and delta y is change in y. The delta x is x2 minus x1 and delta y is y2 minus y1. M is the slope. Um, we calculate m equals to delta y upon delta x. In step 4, we have to calculate three cases. First, if um, m is less than equal to 1. In case 1, if m is less than equal to 1, then x change in unit intervals, y moves with deviation. Xk plus 1, yk plus 1 equals to xk plus 1, yk plus 1. In case 2, m is greater than 1, then x moves with deviation y in unit interval. Xk plus 1 equals to xk plus 1 upon m, xk plus 1 upon m. In step 5, we will repeat step 4 until we find the ending point of the line. And in step 6, we have to stop. Now we will discuss about this algorithm with the help of example. So we have clear explanation. Let us, our example is for line segment between 1 and 7 and 11 and 17. So we have coordinates. The starting point is x1, y1 and the uh, ending point is x2 y2. We have starting point 1 comma 7 and ending point 11 comma 17. First we have to calculate delta x and delta y and m. Now delta x is x2 minus x1 equals to, we have to find the value of delta x. So we have to calculate the value of x. Now we have to put the value of x2 and x1 in delta x. So we have to find the value of delta x. So um, we um, we get the value of x2 is 11 and x1 is 1. Then we have to find the value of x is 10. And now as usual, we find the value of y, delta y. So we put the value of y2 and y1 is 17 and y1 is 7. Now we have to find, now we get the value of delta y is 10. Now we have find the value of delta x and delta y. The value of delta x is 10 and the value of delta y is 10. Now we have to find the slope. The slope is, we put the value of delta y and delta x in the formula of slope. So we put the value and we get the answer is 1. Now the slope is 1. Now we have to calculate the number of steps until we uh, couldn't find the value. Matlab, means In the third, now we calculate the value of steps. Delta x equal to delta y equals to delta 10. Then the number of step is 10. Now we have to calculate. Then the value we find is the number of steps in this solution is 10. Now we get the value of m, and the value of m is 1. In the third case is satisfied. Now we move on the next step. And for this graph slope in this picture, we have to find the values, the 10 values we get. We can put xk and yk. Now we find the value of xk plus 1 and yk plus 1. We put the values until we can't satisfy. So and we put the values until we can't get the value. So the value we put to xk and yk plus 1. We get xk plus 1 and yk plus 1. We put the value until um, we get the final answer in ending points 11 and 17, and the value we get xk plus 1 and k plus 1 is 11 and 17. Next, in step 4 we will repeat the step 3 until we get the endpoints of the line. In step 5 we stop the algorithm, and in the graph we have explained the 10 steps, means 10 points that we get. In the graph we have coordinates to draw line is p1, p2, p3, p5 up to p10. In x we have the value of x, and in y we have the value of y. So we get the points p1, p2 up to p10. Means when we get the value of endpoint in p10 11 comma 17, we get the endpoints. Means until we find the endpoint we can did the algorithm. So this is algorithm, DDA, digital differential analyzer. So I hope you will understand. Thank you for watching this video.